everyone. Oh, you hear me well? Yeah, I have a tough act to follow. That's a presentation from Chris. I think was pretty insightful. But before we get started with my presentation, I wanted to mention I think people are curious. A number of you already asked me what happened to your arm. So I thought I will get this out of the way. I went here in Berlin to this wonderful thing as indoor skydiving. Yes, and there is such a thing as indoor skydiving, which is pretty cool. And I unfortunately dislocated my shoulder. Not from hitting everyone, but just from all that wind blowing at 200 kilometers an hour. And then I have a wonderful tour of the Berlin hospital system right here, and my first experience riding with lights and sounds, so it was very wonderful. Well, at least that is a positive way I prefer to look at things. That's what happened. Well, anyway, now going back to the presentation. This presentation will be a high-level overview. As I signed up for this topic and started looking at that, I found out, well, if you really look at 45 minutes or so, you can't really cover a lot of depth. So it is going to be overview. I hope it will give you some names, right, and things you can Google to find more information. And then in certain things, I'm not an expert. So if you see me being wrong, or if you're saying, well, Peter, what about this? There is an actually better tool for that. Let me know so I update a presentation for the next service, the next presentation, the next time I do it. But before that, let's me ask you this question. What is your take on the cloud? Like how you or your company is using that, if you do? And I think there are pretty much two approaches, at least we at Percona see organization choosing. One of them would be, oh, I go to the cloud, something like AWS, and I really drink the Kool-Aid, and I use a lot of proprietary solution. In database space, that would be Redshift, DynamoDB, Aurora, and all this kind of stuff, which, of course, can be very wonderful and usable, but, of course, that also creates a lock-in where your application can be easily moved to their other cloud. And that's some people do, and some people choose that. The other choice, of course, is to really use the open source approaches, such as coming from this cloud native computing foundation. And I mention that because it really is a fantastic ecosystem which has a lot of projects growing and maturing pretty rapidly. And if you would think, look at 5 years ago, for example, it was just, starting, there was relatively few mature products, right, to compare to the cloud solutions. Right now, the situation is completely different, and you would have open source solution for most of your needs if you choose so. I think with that, we can actually give a cloud its original purpose. And what is that original purpose? Well, if you read some early stage Amazon documentation, presentation, when a cloud was just coming up, they were comparing cloud to electricity, right? Saying, well, it doesn't really make sense for you in most cases to run your own generator, right? It's much easier, more convenient, less expensive to buy utility power. But what is good about utility power, of course, it is standard, it is commodity. When you change your utility provider, you don't have to change your fridge or your TV, right? Like, well, that would happen if you really go all the way with adopting Amazon, right, or other cloud, right? And that is, I think, is a very practical way to use a cloud together with open source software as a commodity infrastructure provider. So I will be talking a lot about the open source projects, right? And I think that would not be surprise for you or my kind of bias to open source or preference, whatever you choose to call them. But what I noticed in the recent years, there is a lot of complexity in open source, right? You can see some projects which are kind of some sort of like a tricky open source, right? We have like some open core source available, right? And all kind of licenses and approaches surrounding the open source projects, right? And a lot of people would ask me kind of in this complexity, well, how do you really think about the open source from a practical standpoint? Especially if you are, you know, somewhere in maybe, you know, like a management chain, not really their developer, right? And I encourage people to ask those 3 questions, pretty much, right? One is, can I deploy the solution I'm looking for in my own environment, my own way, without incurring additional costs? In many cases, you can say, oh, it's open source, but you know, really we have built a lot of the proprietary stuff around it, so you can't really deploy it. Amazon RDS would be a good example, right? They wrap around the open source MySQL version, right? But you know what? Using MySQL alone or RDS experience is not the same thing. The other one is, do I have a broad choice of vendors to help? This is not really open source related, but if it is kind of an open source project which only one developer in the whole universe knows, right? Well, then in practice, it is not a good open source to adopt, both from sustainability standpoint, that person may leave, right? Or in terms of, well, lock-in you practically have to that one person or one company coverage. And the third one is, can you really improve the software to make it better and to solve your needs? And I think that is where a lot of open core projects, for example, break down in this way, because you can say if you would want to participate in that project and build a feature similar to what enterprise version has, well, vendors are probably not going to be looking very openly, right, very positively at your attempt to contribute those things. Well, anyway. Now, in my presentation, I will focus a lot at the Kubernetes, because we see really that as emerging ubiquitous orchestration, right, or really the operating system, you can say, for the cloud, which is getting a lot of traction, both from development standpoint as well as a lot of enterprises, right? I think it has now management mind share, which is important from resource allocation. Saying, hey, you know what, if we embrace Kubernetes, it's kind of going to be efficient, portable, and so on and so forth, right? And if you're not familiar with Kubernetes a lot, I like this picture quite well, right, which kind of shows where the Kubernetes fits, and also what's important, how Kubernetes relates to things like OpenStack, right? Because some people would say, well, you know, like when OpenStack, you know, why Kubernetes and not OpenStack? Well, in many cases, you can use open source or OpenStack and Kubernetes together, where Kubernetes provides you higher level of abstractions, which in many cases, kind of developers can use much more directly, right? And you also can run it on variety providers, right? Like pretty much any cloud server out there have. Okay. Well, with that, my sort of like a preaching session is over, and we can now move to talk specifically about what I promised to talk about, the storage in the cloud. Now, when I talk about storage, I talk about a wide variety of things, like basically, well, what choices do we have to store the data, right? And as developer, you see quite a few different storage types in general, and the databases, well, are you know, just one of them. A lot of those storage type is pretty simple, right, at least of what that group entails. The database on itself is a very complicated universe, right? Which I think is getting more and more complicated. When I started with databases, right, well, relational databases pretty much were only game in town. Well, there were kind of dying XML, right, object-oriented databases, but you know, like vast majority of the market was relational databases. Now we have a graph databases, we have time series, we have, and so on and so forth, right, from a model standpoint, as well as all kind of other design considerations, right, we can have. What is even more interesting, we have a number of database systems which support multiple data models, and some of them may also talk multiple protocols, right? Like, for example, like the ClickHouse that can speak in addition to a native language, PostgreSQL and MySQL protocols, right? Victoria Metrics, that's time series engine. It can support Influx and Graffiti API in addition to a Prometheus-like interface, right? And there are, you know, a bunch of others as well. In terms of purpose and kind of design, which are clustered together, is also a lot of really different approaches to their database as well, which often you would consider especially building the applications at scale. Right? Because if you really are going to store a lot of data and demand a lot of work from a database, you need databases which fits for purpose, because otherwise you may be spending, you know, 10 or even 100 times more money to achieve the same level of performance, which is not a good idea, whatever you think about your business or just if you think about environment. So why are we talking about a distributed in particular? Well, for some that question would be obvious, of course. For others, here is a bit of explanation, right? If you go up to above certain level in your requirements in redundancy, right, on availability, performance, right, or scale of amount of data you have to store, you can't really scale up in a single, whatever, right, like storage environment, volume, right, or whatever. You need some sort of distributed solution. Also, if you look at the cloud, and especially Kubernetes approach, it doesn't really work very well with a, you know, pet model, right? Where you can say, oh my gosh, I have the most important pod in the universe which never ever can go down and restart. It just doesn't work this way, right? I remember what is like 15 years ago, you would find some of those kind of heroes to say, oh, I have this server which I haven't rebooted in 10 years, right? And you know what? It's still kind of plugging along. Yes, I kind of swap maybe a couple of drives from my RAID, but otherwise it's kind of 100% uptime. Well, that is not a way that we design most conventional applications, at least, right, anymore. And so with that model, you need to really design things, assuming what any node can, you know, disappear anytime, and maybe, especially if you are in a public cloud, you won't be able to recover that node or all the data it had on its local storage. So plan for that. So let's look at the storage types and the options which we have in the different clouds. The first group, what I would put, is a commodity storage. What does that mean? Well, that means the storage, right, which is, I think, is a building block which is pretty compatible between the clouds. Migrating between those is often relatively simple, even though it may come under the different names. And that is why it has interfaces which are relatively simple and relatively compatible to each other. Node local storage, right, that is basically your disk, is a great example out there, right? Pretty much every cloud vendor, right, or if you use private cloud, VM, have some sort of solution out there. And they all pretty much behave the same from a high-level standpoint. Performance, though, can very much vary a lot, right? And again, if you come from a database world, storage performance is absolutely critical. Next one would be network block storage, right, or network attached, right? Again, pretty much the same idea, which some storage, which you can mount as a local device. It comes under different names in different cloud vendors, but pretty commodity. The interesting thing here is you also have some additional commercial vendors, which provide some extra solutions, right? Whether that's kind of performance, security, manageability in this space. There are also a number of open source solutions which you can use if you want to build something like block storage, right? Just from the ground up, not relying on any public storage. The next level up, as you would guess, is a file storage. Something similar to your NFS or NAS solution, where instead of block device, you make a file system accessible. Again, there is solution, sometimes multiple solutions for majority of public cloud. You can have also commercial vendors, right, providing their solutions in this case. And also there's obviously open source solutions exist if you want to build that file storage right from the ground up. Right now, again, in a database space, I would say we do not particularly like that, right? Like from early days, storing databases, right, on NFS was really one of the best ways how you can, lose your data, right, or require the data recovery from backup, but for other applications, it can be quite useful. The next one, and I think that is getting increasingly important, is an object store, right? All the clouds have some solutions on their own. I think what is interesting in this case is what S3, right? While coming from Amazon, that became sort of de facto standard, and many providers out there may provide something native, right, on their own, which is kind of better than S3, but then they also acknowledge, well, you know what? Actually, a lot of our users go through S3 emulation layer, just because it became so ubiquitous. And there are a lot of object storage vendors exist in this universe. It's both built in some particular clouds, as well as some vendors are providing S3 interface sort of separately. Some of them are designed for some particular use cases. Say, well, you know what? Often you may want to take backups and store them as S3, and there are actually merits to store your backups away from your primary cloud vendor, right? Because, well, some failures may be global, right, or you may run out in some other issues. There are a number of solutions in the open source space, right, which provide S3 compatible storage too. But I specifically wanted to highlight Minio here, right, I think, which is by far the leader in this space, right? If you really are looking for simple S3 compatible storage, Minio is a great thing to be aware about. Okay, let's look at the databases and data stores now. The thing about them is what they are highly differentiated. And what that means, what if you even have like a similar offering, they are not really easily movable, right, between each other. So you can think about, let's say, AWS has Redshift and Google have a BigQuery, which are kind of both analytical databases, but saying, oh, I want to move my application from Redshift to BigQuery is probably going to be quite complicated, right? Because there are a lot of differences between technologies on many levels. So I think that is where in your conventional or let's say commodity storage types, right? It's often very easy to just use what your cloud provides as a building block, right? So for example, if you're running on Amazon, it's probably like you don't need to try to re-implement S3-like interface on its block storage, like a local disk using Mini or something. That would be impractical, expensive, and so on and so forth, right? There, with databases, it often is a good idea to consider open source solution because the cost of lock-in is significant, and that is also, of course, with that leveraged by the cloud vendors, where cloud databases tends to be quite expensive compared to their infrastructure cost alone. So first, let's look at the queued streams and data pipelines, right? I just group those all together, which are not specifically about being your primary data store in most cases, but about how you can move the data between applications, which is becoming a very important part of a modern data architectures. Right. Now, in this case, you can see what the clouds have provided the large variety of offerings, right, which can be both like their own proprietary solutions as well as so-called managed solution in the cloud, right? Now you have also the third-party proprietary solutions, right, which exist in this case, right? And by the proprietary, I also define here using the questions I spoke about the open source, right? Is it completely open source, right? If we have the open source database technology, but if it's kind of wrapped around of a proprietary management layer, which I cannot just run on my own and say, dear vendor, goodbye, I don't need you anymore, well, then that's not quite open source. There are also a bunch of open source solutions in this space. With Kafka being quite a leader in this case, I think at this point it has a lot of momentum. Now, if you look at relational databases, they are often split in a transactional relational databases, right, or like operational relational databases and analytical, right? While there is some overlap as so-called like hybrid transactional analytical databases, they are relatively small, right? And in many cases, people just use one database type or another. And again, we can see for every cloud there are number of solutions, and they generally come from managed open source version, managed proprietary versions as Oracle, and also maybe built something kind of purpose built in the cloud as well. Same from a proprietary standpoint, number of databases exist. Now, what is interesting in this case is a lot of focus with relational database technologies. The proprietary one is having a cloud version. Many vendors are completely focused on that, right? I know a number of the kind of, especially the new companies started over the last few years, say, hey, you know what, we are not even going to bother with on-prem enterprise support lets people, pick up, maybe open source version of what we are doing, or maybe not, right? And we are going to focus completely on that database as a service cloud, cloud experience, right? That is very common. There is also a lot of choice of relational transactional databases. And I like to look about those databases in kind of those like two buckets. There are some of legacy databases, right? Which I think a database which were built before that kind of idea of cloud first, distributed first. Think about Postgres or MySQL. Well, these are wonderful databases, but they're built with a server in mind, and kind of like, well, think about single servers, maybe you kind of replicate and cluster them together. Versus some of the newer generation databases like Yugabyte, TiDB, right, which are built to be distributed first. And if you think right now, we still have majority of data, majority of back workloads live in those, not cloud purpose-built databases, but that is probably going to change over time as we have more and more, I would say, like a cloud mindset adoption. Now, if you look at the analytical databases, well, I guess you wouldn't be surprised. Again, you see a number of solutions from different cloud vendors. I think I should have updated GCP now. They also released AlloyDB, right, which is kind of PostgreSQL-based analytical solution, right, for GCP. And there is also a lot of proprietary solutions which are not based by the built by the cloud vendors. I think what is interesting in this case is what you will see some of the traction of the companies like Snowflake specifically, right? Has a lot of kind of traction, even though it's not solution of any major clouds. And I think that is because in analytical workloads, there is so much beyond that core database. Like, where do you get the data? Well, can I get the data from a kind of different data sources and a kind of really, join that together? So that becomes often not just a question in the modern analytics of providing the technology to analyze your data, but you often would want to be able to easily on the platform to integrate your data with other data sets, right? To have that like business intelligence. Like, you think about that, well, if I am going to run some multinational company, I probably want to know the currency conversion rate for all the currencies I use, right, for, well, historical, right? Well, it doesn't make sense for every company kind of to to develop that base, right? It's better if it's simply accessible on the platform. Now, looking at relation analytics open source, again, there is a lot of solutions out there. The next one I would mention is the document store, right? That is from a non-relational database, when we can say, hey, we want to store documents, right? And in many of those technologies I mentioned, they can be kind of slightly, gets into kind of multi-purpose, right? Because I think this NoSQL sort of class of a database often can be sliced and diced in so many different ways. From a proprietary, I would mention MongoDB, Enterprise, and Couchbase, which are very well positioned. And from the document store, we have open source and source available. MongoDB, which started as an open source database, unfortunately became source available more recently. And Couchbase community is still open source. What I think is interesting thing happening here is what a lot of relational databases increasingly push with JSON support, right, and even let's say some interfaces, so you can use them as documents store. Think MySQL doc store. PostgreSQL has a bunch of interfaces. Even SQL standard has like a JSON extension, right? So there is a lot of cross-pollination is going store. For key value stores, I would separate kind of two different use cases. There are some of them which are designed more kind of for caching, right? So in-memory optimized for performance, but your data may get lost, right? I think in the key value stores, if you look at, there is a lot of fragmentation, but I think Redis has emerged really as when you think like key value store and some additional applications, that is by far the most used database, right? And in open source environment, I wanted to highlight a couple of other also technology. Memcached, which was kind of category redefiner like a decade and like probably like by now like almost 2 decades ago, and KeyDB, which is sort of one of the Redis compatible solutions. If you look at a persistent value store, typically in the clouds, you have mostly the same solutions, which can be often tuned, right, in terms of what kind of durability settings you want to have. Actually same to the open source actually kind of same to the proprietary solution. But I think in this case, if you're really looking not like a very fast in memory stuff, but more of a key value semi-model persistence, there is a lot more different databases emerge. And also kind of as usually, as same as with documents, you can see relational databases here. In many cases, people can say, well, you know what, maybe we don't need to kind of super optimize things. So let's just use our relational database for simple key value store purpose. We know it. It works reasonably well. And, some people just use that. Time series, I think, is another interesting emerging database market. I think especially with things like internet, IoT, right? The observability, we got a lot of attention and focus on time series, right? What is interesting is what you would have some specific time series database provided, but a lot of them are also starting to, as it happens with the cloud, if they really cannot fight that kind of an open source standard raising anymore, we just choose to adopt it, right? Like AWS has a time stream, but they also have managed Prometheus servers, right? At this point, which I forgot to add out here. A lot of the products in this space, they have some enterprise version, right? So you have some open core or some other space as well as cloud solutions, right? And what are the open source one? Here are again quite fragmented ecosystem. A lot of choices. Prometheus has a lot of traction, I think, especially in Kubernetes observability space. I think TimescaleDB are doing quite interesting work, kind of building solution which is time series capable, but also PostgreSQL compatible, right? And they have kind of slightly crippled open source version which you can use. There are a lot of other takes on Prometheus ecosystems like M3, Cortex, Thanos. There is also Victoria Metrics, right, which I mentioned. So there is a lot of things going on in this in this ecosystem. So the next I would probably should mention is, well, I'm speaking here as a CEO and founder of Percona. So what does Percona has to do with all of this, right? I mean, well, as you probably heard from the start of my presentation, we are really focused on the open source and kind of open source for real. And we really want to push the boundaries of what you can do without leaving that open source ecosystem with in the open source database space. And with databases, unfortunately as well, relatively small company, we cannot cover all that wealth of databases I mentioned. So we focus on their most common databases, which for us is MySQL, MongoDB, and Postgres. As I mentioned, MongoDB is unfortunately not open source anymore, but well, when we started focus on that technology, it was, and when they went to source available, well, that would not be appropriate for us to dump our customers and say, well, you know what, we are not able to support you anymore. And what we focus at Percona is we provide our distributions for MySQL, MongoDB, Postgres, and that tends to be kind of enhanced version where we implement as an open source a lot of enterprise features, which otherwise would be only available in commercial editions, as well as do a number of other extensions. And we also invest a lot in Kubernetes operators for those technologies. And I think that is a very interesting what we see happening with operators in databases, right? Because what I mentioned before, a lot of new generation companies really focus on database as a service, because that is the only thing they consider thinking is going to matter. And with that, they often maybe intentionally neglect the operators. Think about Oracle. What is Oracle thinking about? What is the way the Oracle wants it to run MySQL? Anybody knows? On Oracle Cloud, right? So we don't want actually to have like a competition to that as having a good open source operator, right? So they kind of released something, right? But that is not really very mature, useful operator, right? In this case, if you think about other solutions, it's often the same in the same boat, right? So I think the work we are doing with operators has been quite helpful for a lot in this ecosystem. And what we are also building is an open source product called Percona Monitoring Management, right? This is the tool where we focus on both database observability as well as number of management functions. Specifically what we find, while for certain people who are like, I would call like Kubernetes natives, you give them operators and they can say, oh my gosh, that's fantastic, right? I'll just, have my YAML files and a version control, right? And have my fully repeatable infrastructure. It's wonderful, right? But then there is also other types of users who say, well, you know what, we want RDS replacement. We want to be able to kind of deploy database in a couple of clicks, right, and so on and so forth, right? And for those folks, there is not really good, like fully open source solutions right now, right? And that is what we are building as a part of our work in Percona Monitoring Management. Okay, now to sum things up, if you will. Well, first, you can see the ecosystem of storage is, quite complicated if you really go deep in this case, right? Well, but in reality, of course, like you typically would know what your requirements are, not have as massive technology, choice of technologies to peak. Well, and frankly, there are also some organizational limitations, right? I would say often you do not want to introduce the new technologies, right, compared to what you're using already, unless you really provide a lot of value. Because, well, building that development experience, having a team or vendor relationship, that has additional cost. And if you just, you know, have relatively modest needs, often using technology which may not, you know, be absolutely best for the purpose can be just good enough. And the main thing I wanted to highlight is wherever category of storage you're looking at, there are actually a number of open source choices are available. Some of them are quite mature, right, and broadly used, and some of them are getting there. And if you're looking forward a few years from now, I think we'll have even better open source choices for all of our storage needs. With that, that's all I wanted to say, and I'll be happy to answer some questions.